This video is just a few questions on logic, so some truth tables and some circuits. So the first one that we've got here, typical sort of exam question that we've got, and it's A, XOR B is the table. So XOR, the symbol for XOR would be like this if we were doing that, or if we were drawing the gate, we've got like a double back to XOR like this. And XOR is only going to give us a 1 if these are opposite. So if they're both 1s, it's going to give us a 0. So 0 and 0 is, well, 0. 0 and 1 is going to be 1 because they're opposite. 1 and 0, 1 because they're opposite. But 1 and 1, they're both the same. So even though they're both 1s, that's going to be a 0. So that's our idea for XOR. So then there's a shade the lozenge style question here. And we just have to choose what the expression is from A, B, C, or D. So A is going into a NOT gate, and B is going into a NOT gate. So that's our first kind of clue. So we've got quite a few options that look like that might be the case. We've got an OR gate here and an AND gate there. So our last thing there's an AND. So if we think about it from the point of view of what happens first, then we've got not A and we've got not B, and they're ORed, and then we're ANDing with C. So not A happens, not B happens, they get ORed together, and they're inside these brackets to make sure that happens first, and then they're ANDed at the end. So the order of what we're going to do AND normally takes precedence, but if we've got brackets, that stops that happening. So inside our bracket there, we've got not A, inside we've got another one, not B, and then OR is inside another set of brackets. So that one's the correct one for that one. So then we've got another truth table, and this time it's for logical AND. So we draw AND something like this, or it's A dot B, A and B. And in this case, the only time it's going to be 1 is if both inputs are 1. And all of the other times, it's going to be 0. So that's the AND gate. So then we've got a game sensor. So a game uses 3 sensors. Let's try and get it so you can see that. A red light at the end R switches on if all the following conditions are true. So if D is off, so that's going to give us a clue first of all. If D is off, because if D is off, we need to deal with that as an idea first of all. So we'll think about how that works. So what we need to make sure is that if D is off, we're going to not that there. If sensor L is on, sensor W is on. So L and W, they need to be both on. So I put that into an AND gate like that. And then it's all of the following. So all of these things have to be the case. So therefore, we need to make sure that they are all the case by having another AND gate. And don't forget to connect it to the end. So sensor D is off. So if D is 0 and it's off, then it'll appear as a 1 here. If sensor L is on with a 1 and W is on with a 1, then that will appear as a 1 here. And the AND gate will appear as a 1 there, and the red light will come on. So if alternatively to that, we can check this out and see. So if sensor D is on, let me try and get the right device. There we go. So if sensor D is on, it's a 1, it'll appear as a 0 here. So even if both of these are on, the 1 and the 0 in the AND gate will mean that we've got a 0 at this end, like that. And when you've got a circuit like this, it's best to think about them perhaps in order and think about what needs to be the case. So if it says all of the following or all things, we're going to probably end up with an AND gate at the end because everything needs to be on at the same time. So if it's one or the other, we're thinking about an OR gate probably. And when we've got something that needs to be off, it's likely there that we're going to need a NOT gate to make sure that works in the way it should. Okay, so then we've got this idea of writing an expression for something a bit similar. So a green light in the game switches on if all of the following, so again we're thinking about everything, are true. So if sensor D is off, so we could think not D is off. Sensor L is off, so probably we AND not L, and all of the following, sensor W is on, so AND W. And even though that seems very simple, that is a good answer for that. That is the answer for that, really. The best answer is the easiest one to think about. So we've used a Boolean expression, so we've used dots for AND. So if we've got AND, we're looking at A dot B. If we've got OR, we're looking at A or B, and XOR A, XOR B, like that. And if we've got a NOT, so not A and B, for example, might look like that, not A and B, or just not A for a single one. So we could have any of those things. That's the kind of notation we're looking for. You need to think about AND, or, not, and potentially XOR as well. So there's a few questions on logic and circuits.